The instructions for this problem say to solve each system by using elementary row operations on the equation or on the augmented matrix, and follow the systematic elimination procedure described in this section. To do that, we first need to write down our augmented matrix. These are the coefficients of each equation. For the first equation, we have 1, 5, and 7. For the second equation, we have -2, -7, and -5. Now, just to give you a little bit of explanation, this first vertical column corresponds to the coefficients for x1. This second column are the coefficients for x2. This augmentation bar that you see here is actually just representing our equal sign, and these vertical numbers in this last column represent the answers to the right side of the equal sign. So the first thing we want to do is eliminate this -2. To do that, we would multiply row 1 by 2, add that to row 2, and then put our result in row 2. What you should notice is that row 1 does not change, so we could just rewrite that as 1, 5, and 7. Next, we perform the row operation. 2 times 1 is 2, plus -2 is 0. 5 times 2 is 10, plus -7 is 3. 7 times 2 is 14, plus -5 is 9. Next, we want to make this 3 a 1. We can do that by multiplying row 2 by a third, and putting our result back in row 2. Again, row 1 does not change, it stays the same. So we could just rewrite row 1 again as 1, 5, and 7. Next, we multiply row 2 by a third. 0 times a third is 0. 3 times a third is 1. And 9 times a third is 3. Next, we want to eliminate this 5. We can do that by multiplying row 2 by -5 and then adding it to row 1. So that would look something like this. -5 times row 2 plus row 1. This time we're going to put our result in row 1. So in this case, row 2 doesn't change, so we can start by rewriting row 2 as 0, 1, and 3. Then perform this row operation. -5 times 0 is 0, plus 1 is still 1. -5 times 1 is -5, plus 5 is 0. -5 times 3 is -15. -15 plus 7 is -8. Finally, we could rewrite this as a solution. If you read this left to right, it would be x1 equals -8. Down here we have x2 equals 3. Now you could also write this as an ordered pair, -8, 3, or soon in matrix notation as a 2 by 1 matrix, -8, 3.